Okay, so we will just going to start this one that is related to the objectives of the digital signal processing. In this one, we will discuss the concepts by which we will try to achieve our objectives which we have decided for this subject. As we know, first of all, we have to discuss the system. What is the system? Because as in the previous lecture, we have discussed being an engineer, it's our duty that we have to utilize the rules, regulations given by the mathematicians, scientists, and other society persons for to design a new system or to enhance the performance of the existing system as well as to maintain them for the welfare of the society. So first of all, we must be knowing what is the system. As we know, system operates on the signal in order to achieve the decided goal or the target, or we can say system operates on the signal in order to extract the desired information. And in order to achieve this goal or in order to perform this objective, a system can be defined as a collection of parts that works together to achieve a goal or the task, or we can say a set of the it is a system is a set of the objects and relationship among the objects viewed as a whole here. So here the system may also be named as a process that operates on the input, and if we are getting here the desired output, it's okay. Otherwise, there is a need of the reinforcement with the help of the feedback. And we know we have to apply here the effective methodology in order to enhance the performance of the existing system. And effectiveness comes from the human skills, some using some software or using some hardware here. So in order to design any system, or we can say if we are interested to define any system for the purpose of the enhancement of the system, then we have to go through these aspects here. That is, what is the human skill, software, hardware, and how they are correlated, means what is the function that will depend upon these parameters, that is the human skills, software, and hardware. And our goal is to develop an efficient algorithm or efficient system in order to achieve the given target here. So if any requirement is given, suppose we have to design any system and requirements are given, then whatever are the requirements, those are said to be the ideal. For example, say if we are a student and we are going to be processed through an examination or the test or the viva, then our requirements will be to achieve the 100% marks. That is the ideal one. But due to some practical aspects or some practical the constraints, there must be a compromise between this ideal requirement and the practical approaches here. So whatever our requirements are given in order to design a system, those requirements have to be converted into the form of the specification by applying here the practical approaches. Okay, so first is that we are interested to design any system. So first of all, we have defined the system, and then whatever are the requirements given to design any particular type of the system, those requirements have to be converted in the form of the specification with the help of the practical approaches. Now, when we say approaches are the algorithms, are the rules, regulations, are the model, again, it is related to the mathematical models, are the rules, regulations given by mathematicians and the scientists and other approaches also. So here, when we get the specification, this is named as the determination of the parameters. So from the requirements, we have derived the parameters here. And after the derivation of the parameter, we have to decide whether we have interested for the static system or the dynamic system. Static system are those systems which depends upon only the present inputs and not depends upon the previous input or the previous outputs. It means if we are interested to describe mathematically any static system, then those systems will be described only by the polynomials. Why we are saying polynomials? Because if we are interested in order to represent any system that is capable to store the previous input or the previous output, or that is capable to store the information, that must be defined either with the help of the differential equation or with the help of the difference equation. Why? Because we know if we are trying to define any mathematical model of the analog system or the continuous domain signal system, that is said to be the here the having the capability to store the previous information. It means analog system must include the capacitors and inductors, and as we know, due to its bulky nature and other parameters, we avoid the inductor here and we will select only the capacitor here. Now if we select the capacitor, then the equations will be defined by the differential equations here. Similarly, if we are in the digital domain and we are interested to describe or to define any system that have the capability to store the previous information, then it is only possible when the system has the flip-flop, because the flip-flop stores one bit information. And when we say flip-flop, one bit information is stored, what and storing of the information, as we have discussed in the previous class, that is in yesterday, that storing capability means it has capability to reproduce it at the later required time. So if the signal or the here the information will be reproduced at the later time, we can say at that time that is the delayed information or the delayed here the quantity. So that is also defined by the delay here. And when we include the delay, that is defined by 1 bit delay. So if we are trying to discuss it at the nth in discrete time, then the previous information will be the n minus 1. So x n minus 1 or the y n minus 1, like that, x n minus k, y n minus k. This type of the terms must be there here, and these are named as the difference equation. So if we are using the differential or the difference equation, then that will become here the dynamic system. And if the system is static, naturally that will be represented by the polynomials only. Okay, is that clear? Any problem you may ask at any time. Please don't hesitate. So, and after this decision, that is whether we are interested for the static or the dynamic system, next decision must be whether we are interested for the analog system or the digital system. Naturally, as we know, the dynamic system is far better than the static system, so we will move for the dynamic system. And if we have selected here this domain, that is the dynamic system, then again we have to decide whether it is the analog or the digital. If it is analog, naturally, as we have discussed, that will be described with the help of the differential equations. By a simple differential equation, a complex differential equation, or that may be represented with the help of a set of the differential equations. Similarly, we can select, if we have selected the digital system, then that will be described by the differential equation. And now, if we here in the first step, we have defined the system, or we have defined our problem, and from that problem or from that requirement that is related to the system, we have derived some parameters that is named as the determination of the parameters. So here the definition, then determination of the parameters, and the third stage is the decision. Here we have taken the decision that which type of the system or which type of the mathematical model will be most suitable for the required purposes. Now, if we suppose we consider here the this one, that is the difference equation here. Naturally, we are moving towards the concept of the digital signal processing. So digit means that will be represented by the discrete value digits, and in the binary system that will be the 0 and 1, that is the binary digit, and that's why we call it the bit, that is the binary digit. So if we use here the digital signal, then the digital signal will be represented by the here the digital signal. It will be represent it must have the values of the xn minus k and the yn minus k, where the xn is the input to this digital. Suppose this is the digital system, the input is the xn and the output is the yn, and there must be a capability to store the previous output and the previous input as well as the output also. That's why the yn, that is the response of that system, must be a function of the xn minus k and the yn minus k. And now if we write the equation, that is the all yn and all yn that is related with the yn or yn minus k are left side, and this is on the right side xn minus k, then we can say this is a general mathematical model of a digital system here. So this may be written as something like in this manner, that is the summation of the here the bk yn minus k, and the k will start from 0 to n, and at the right side this will become here the akx n minus k, k will start from 0 to m. And now if we assume that b naught is equal to 1, and except only the b naught, all these terms has been shifted towards the right side here. So we will get this type of the equation. Yn is equal to minus summation, because we have considered the k is equal to 0 towards the left side, and that will become the b naught yn, because the k is 0, so, and b naught has been assumed as 1. So this equation will become here the k here the summation with the negative sign, summation k is equal to 1 to n vk yn minus k plus k 0 to m akx n minus k. Very simple, nothing special has to be done here. Now if we have gone through this model, then now each and every step will be very simple for us. So this is a general model of the digital system here, and since it is capable to process the digital type of the information, naturally it will be named for the digital processing system, model for the digital processing system here. Now if we assume here that all the AKs, first suppose all BKs are 0, all BKs, that is this is the coefficient related to the yn, and AK is the coefficient associated with the xn. Now if we assume all the BKs are 0 except only B naught here, because B naught has been assumed a 1, and so this term will vanish from here, and we will get a equation that is the yn is equal to summation k is equal to 0 to m ak xn minus k. I'm again repeating. If we assume here the yn depends only those terms which have the AKs, means all BKs will be 0 except the B naught, and that B naught will become 1. So this equation will be written as the yn is equal to summation of the AK multiplied by xn minus k, and the limit of the here the k is from 0 to m, 0 to m. It means now this has only one term. In place of the two terms, now there will be only one term. And if we again see carefully here, then we will find that if we assume as m is equal to 2, that is the k starts from 0 to 2 here, then this will become the a0 xn plus a1 xn minus 1 plus a2 xn minus 2. Okay. Similarly, we can assume any other values here. But first of all, we will discuss for the k is equal to 0 to 2 here. And we have the three terms. Again, repeating it, a0 xn plus a1 xn minus 1 plus a2 xn minus 2. Students may note it in their notebook, and I think that will be better for them. So here, now if you see, then you will find there are the three terms and all are related to the xn, having the different stages of the xn. First, present xn, delayed by, second is the delayed by 1 unit, 1 bit, third is the delayed by again 1 bit here. And all have their different coefficients, a0, a1 and a2. Now, keeping in mind this equation, again move to a very simple mathematical calculation. Suppose we are interested in order to get the average of the three values, like these values are given the 1 to 3 here. So how we calculate the average of these values? 1 plus 2 plus 3 divided by total number of the numbers here, and there are the 3. So this will become the 1 plus 2 plus 3 divided by 3. Now this may also be written as 1 by 3 multiplied by 1 plus 1 by 3 multiplied by 2 plus 1 by 3 multiplied by 3. Am I right? Okay. So now if we compare these two equations, one derived from this model and the second which we use during the time of the taking the average of the three sequences or the three values here, then we will find both are more or less same, but the difference exists only with the coefficients. In the average case, when we try to get the average, at that time all the coefficients are same, but in this case the coefficients are changing their values, or we can say coefficients are moving. So if we consider this type of the arrangement, that is the yn is represented only by the second term, then this model is known as the moving average model of the digital signal processing system or the digital system. Moving average model, MA. MA model, that is the moving average model of the digital signal processing system. Again, come to the second term, here the first term. Now suppose all the AKs are 0 except only the A naught. If A naught exists, then this will become the A naught xn only here, and there will be no summation term, and this will exist as shown here. Now what is happening? There is a term A naught xn, or for the simplicity we can assume again A naught is equal to 1. Then there is only one term, that is the xn. This is the second case. Now we have moved to the second case. In the first case, we have discussed and decided and defined that if the second term exists, then that model will be known as the moving average model. Now we are moving to this one, this term here, and assuming the same condition, that is A naught exists and all AKs have their values equal to 0. Now, and this will be this term here plus xn is the input. So what is the meaning of this one? Means the system will be disturbed or excited by the xn, and whatever is the output, that will be again taken as the input for the system, and so on. Means auto regression takes place in this one. So the second model, when we assume that y and k associated with the bks, all terms exist, but the terms having the coefficients are the ak's, vanishes except only the a naught. Means all ak's are 0 except only the a naught here. Then this model will be known as the auto-regressive model, AR model. Okay, and in total, if we see the total model of this one here, then this will be named as the AR. This will become the AR model, and this will become the moving average model. So this will become the ARMA model. Which model? Yes, please respond. Yes, respond, please. Response is required. Yeah, speak loudly. Yeah, very good. Which model?
ARMA model.
Very good. Your name is
Ashwarya.
Ashara. Very good. Very good. Good. Keep it up. So, ARMA model, that is auto-regressive moving average model. So, and this section is moving average. This is auto-regressive. So, the total one is known as the auto-regressive moving average model, ARMA model. Now, if we see that this term here, that is the for the moving average. During the time of the moving average model, there is no this term. This term is equal to 0 here. So what will be the structure of this one? It means there is no feedback. Whatever is the input, that will be here the modified. Means the system will operate only upon the inputs here, present or the previous inputs, and accordingly we will get here the output. That is without any feedback. If any system is without any feedback, and suppose that is disturbed by some impulse as the input, then what will be the impulse response? If that system is disturbed by any impulse, then what will happen? The disturbance will take place, and accordingly we will get the response. But after certain duration, it will be in settled position. Why? Because the impulse has very short duration. And as we know, during the time of the testing of any system which we have designed or which we have to design, we use such type of the signals for the test as a test signal, like the impulse, pulse, or step function, not the sinusoidal signal. Because if you see the architecture of the, if you see the shape of the pulse, then in the first stage there is sudden change from 0 to 1, then it remains 1 for a certain duration, again changes 1 to 0. So there are the two sudden changes. There are the two situations. There are the two circumstances when the abrupt changes are taking place here, and it means and that is changing within a 0 duration without any sufficient time. The situation has been changed, and if we have no time to face any higher situation, then that is named as the worst situation. So in order to in order to test the system, we use pulse. It means there are the two worst situation, and when it has the same value, that is known as the best value, best situation. So whatever is the system, whether that is the system designed by the human being or human being itself as a system, so these systems are tested in the best and worst situations. That's why we use such type of the signals for the purpose of the testing of our designed system. If in these two extreme positions system are working properly, then it means in the between these two situations, naturally the system's performance will remain okay. So again, coming to the point here, that if there is no feedback and that this is disturbed by any input, then whatever is the response that will be settled by a certain duration, it means we will get here the finite response after certain duration. And response due to which one? Due to the impulse as the disturbance or the input. So this type of the system will be known as the FIR, finite impulse response system, because we are getting here the finite values after certain duration here. But in the second case, auto regression means what? If the system is disturbed by the present input, then whatever is the output, again that will be considered as the input. Auto regression takes place here. So that disturbance will again be considered as the input, and the system will be again disturbed. Again, whatever is the disturbance comes to the input in the manner of the auto regression. So what will happen? Infinite duration will take place in order to get the impulse response of the system. So it will be known as the IIR system. That is the infinite impulse response. So the first one is moving average. If this terms exist, moving average model, and if this term exists along with the this xn also here, then that is known as the auto regression. And in total or in general, if there are both the terms a case and b case, then that will be known as the ARM model. And the first one is also known as the FIR, and the second one is known as the IIR. अभी तक ये दो मॉडल पढ़ के चलते हैं, आगे हम और भी डिस्कस करेंगे. Similarly, we can discuss the same thing for the analog system, and in the case of the analog system, the system will be represented by the differential equations here. And if the for the here the single dimension, there will be the single summation series, and for the two-dimensional signals, there will be the two summation series here. So these are the representation for the analog and the digital system, either with the help of the difference equation or with the help of the differential equation. If the system is analog, that will be represented by the differential equation. System is digital, that will be represented by the difference equation. So it is the representation in the time domain. And we have also derived this one from the decision, our decision here. Then that will be known as the next step, that is the derivation. And if we see the derivation, now we will find here what will be the architecture. Means if the input is xn, then there will be a delay. The output of that delay will be the xn minus 1, and then that will be multiplied by the a1. It will become the a1 xn minus 1, and the previous one will be added to this one. So this will become the a naught xn plus a1 xn minus 1. It means we will get here the some architecture. That's why this is also named as the realization. We will discuss it in detail. Just we are here trying to cover the overview in order to make a here what is our plan. We are just going to discuss here. We are just trying to discuss the map, so that according to that map we can build our building here. So here this is the plan which we will cover in our DSP here. Now, if we again see here the A case and B case as the coefficients, then A case and B case will describe here the architectures or the realization. It means they will decide the components, values of the components, and if these values of the components are fixed with respect to time, that will be known as the LTI system. If in any difference equation or in any differential equation, if the coefficients are constant, then those equations are named as the mathematical equations for the LTI system. That is the deterministic rules. That is the deterministic approach, deterministic model, deterministic equations for the given systems here. Now, if these AKs and VKs are changing their values with respect to time, for example, suppose we again consider the same example, the simplest example of our electrical or electronics branch or the stream, that is the RC filter. If we are changing the values of the R, as we know that in the transfer function or in the mathematical model, RC will behave like a coefficient. Coefficient is changing, it means the value of the R and C is changing. Coefficient is not changing, means the value of the R and C remains constant. Now, if the R and C remains constant, naturally we will get a particular frequency. And filter or the system will be suitable for that particular frequency. Cutoff frequency will be a deterministic frequency, a defined frequency. Now, if the R and C are changing their values, then what will happen? The coefficient is changing. So here the filters cutoff frequency will be different for the different situation or the different values of the R and C. It means it is not deterministic, but it is random. So that will be named as the adaptive model or the stochastic model. And what is the application of this one? For example, if we are interested in order to filter the noise, so we are not aware with the frequency associated with the noise. So for this type of the unwanted random signals, for their filtration purposes, we have to use the adaptive system. That is the coefficients AKs and BKs are changing their values with respect to time here. So if the AKs and BKs are constant, that will be known as the LTI system. If they are changing their values, that will be named as the adaptive system. Again, coming to the same model, please don't be confused. Be focused. Here we have, this is the ARMA model that is defined in the time domain with the help of the differential equation, and that will be also categorized into the AR or the MA model, FIR or the IIR model, and now we are defining whatever is the model, whether that one is the AR, MA, FIR or IIR. If the coefficients are fixed or the coefficients are not changing their values with respect to time, that will be known as the LTI system. And if the coefficients are changing their values with respect to time, they will be named as the adaptive system. Now the response type, what will be the response type of the system? Means that system is suitable for the lower frequencies, higher frequencies, or for the range of the frequencies, or that filter is that filter will block a range of the frequencies. So accordingly, we will here the categorize them: low pass, high pass, band stop filter. Okay. So again, we will move towards the design methods. In order to design methods, we have to select which method, either for the FIR, that is the moving average model, or for the IIR, auto regressive model here. Now, after this discussion, again, we will come to this point here, response type. Response will be defined with the help of the frequencies. And here the equations are described in time domain. It means there is need of the transformation for the complete analysis of the system in time domain as well as in the frequency domain. And there are so many types of the transformation, like the Laplace transformation or the jet transformation. Now come to these points here. Laplace transformation or the jet transformation. Laplace transformation are used for the differential equations. Means Laplace transformation will be applied for the differential equation, and jet transformation will be applied to the difference equation for the digital system. And if in the case of the Laplace transformed, if the S is replaced by j omega, or in the Z transformed case, Z is replaced by e to power j omega. Generally, what happens? S is equal to sigma plus j omega, and Z is equal to r e to power j omega. But we are here the assuming only the second portion, that is we are here the discarding the real portion, because that is responsible for the damping oscillation only here. So here, if we replace s by j omega or the by e to power j omega, that transformed equation will become the Fourier transformed equation. Why the Fourier transformed equation? Because now that will be a function of the j omega, complex function of the j omega, having the two values, one magnitude and the second one is the phase, and both will be function of the frequency. Means amplitude is also changing with respect to frequency, and the phase is also changing with respect to frequency. When amplitude is changing with respect to frequency, that will be named as the amplitude response, and when the phase is changing with respect to frequency, that will be named as the phase response. Okay, so Laplace transform, Z transform, and the Fourier transform. Now, if the Fourier transform is applied to the discrete time signals, then that will become the DTFT, discrete time Fourier transformation. But in the discrete time Fourier transformation, what will happen? There will be a term like the e to power j k n omega, like that. But this type of the toroidal function is analog in nature, means that will rotate or in either in the clockwise or in the anti-clockwise, but the nature will be the continuous. And we are interested for the digital processing, that is the signal has to be processed digitally. So again there is a need of the discretization. So the DTFT will be again sampled or the discretized, and that will become the discrete version of the DTFT. That is the discretization of the DTFT, and that is known as the DFT, discrete Fourier transformation. And now if we again see in the DFT, then in the DFT there will be a toroidal function which we have discussed, e to power j k n omega, like that, and it has the property of the symmetricity and the periodicity. So if we exploit this property, that the symmetricity and the periodicity, then naturally the number of the multiplications and additions will be reduced. And if the additions and multiplications have been reduced, it means the processing will be fast. And now that is named as the fast Fourier transformation. This is the concept which we have gone from first year to till date in the mathematics for the different types of the transformation. Laplace transformation, Z transformation, Fourier transformation, discrete time Fourier transformation, DFT, discrete. This is the discrete time Fourier transformation, and this is the discrete Fourier transformation, FFT, fast Fourier transformation. Now, if we see in all these type of the Fourier transformation, what is happening? These are suitable only for those type of the signals which are stationary in nature, because they are represented by the terms e to power j omega t, or like the sin omega t and cos omega t, and it represents that it is a function of a particular frequency. But if we are interested in order to analyze any signal like the speech signal, etc., then what happens? The frequency is changing. So frequency is not fixed here. But in the first case, either omega t is the primary frequency, and we will get here the harmonics of those frequencies. But in the second case, speech, etc., here there is a number of the frequencies, and that will be known as the non-stationary signal. So for the non-stationary signal, for the purpose of the analysis, there is need of the time and frequency, both analysis in parallel, so that we can analyze what is the role of a particular frequency at a particular time. Because if we are using this type of the transformation, then either we can analyze the signal either in the time domain or in the frequency domain, not both at the same time. So by using this type of the concept, we use there is a concept of the STFT short time Fourier transformation, that is the total duration will be divided into the smaller section and then Fourier transformation will be applied. And next is the WT, wavelet transformation. As in these cases, the Fourier transformation, DTFT, DFT, FFT, the sinusoidal function is considered as a basic function. Here, the any a function, wavelet function, will be utilized as a basic function, and a family of the wavelet function will be generated, and hence non-stationary signal will be analyzed using this concept, and this is known as the wavelet transformation. And if we are using the continuous domain, that will become the CWT, continuous wavelet transformation. For the discrete, it will be named as the DWT. So again, we are just coming to some of the concept here. We have defined the problem, then we have discussed how the parameters will be decided, then decision, we have discussed the decision, how we will decide what is the type of the system, whether it is the static or dynamic, analog or the digital, then derivation of that system and the realization. Again, here we have to determine what will be the response type and what are the design methods along with the analysis here. यहां तक हम लोग अभी डिस्कस कर चुके हैं। अब थोड़ा इसके आगे बढ़ते हैं हम, और जस्ट ये समरी है क्योंकि ये हमारे दिमाग में हमेशा बना रहना चाहिए। सो आफ्टर दिस वन, एज वी नो, there is a need of the implementation, and during the time of implementation, what will happen? A processor is required either to be implemented in software or to be implemented in hardware. अभी तक जो हम assume करते चले आ रहे हैं, क्या करते चले आ रहे हैं, whatever is the information from one domain, that will be transformed into another domain, but it's not true. That will depend upon the word length of the processor. So due to this limitation, there is a need of the approximation. So, and using the different types of the approximation method, here the system will be designed. The approximation methods for the moving average are the different, approximation for the auto regressions are the different. So we will discuss the different types of the approximation method. That is the for the FIR filter, we will discuss the equiripple, least squares, window, least squares, etc. here. And for the IIR, or the here we will discuss the designing of the filter in analog domain, that will be transformed into the digital domain, and for that purpose we will use here the Butterworth approximation, Chebyshев approximation, elliptic operation, etc. here. And then after designing, we will analyze the performance of the design system here on the basis of the 4 parameters. As yesterday we have discussed that in order to decide the value of a diamond, the 4 C's are required, that are the carat, cut, color, and the clarity. And we have also discussed that in order to decide the personality of a person, 9 P's are required. Similarly, in order to decide the performance of a design system, we have to check the 4 parameters. One is the energy, that is power consumption. Second is what is the area required for the purpose of the implementation, either the area on the silicon chip wafer or the memory space. And the second is the speed, that is also related to the delay. What is the speed, what are the delay propagation, and the finite word length effect. That is, if we apply here the this quantization process according to the different processors, then what will be the effect on the performance of that system? That will be known as the finite word length effect. And after this one, again we will here the after quantization, we will try to convert this algorithm in such a manner that is VLSI implementable. And if that one is VLSI implementable, then we, for the purpose of the mapping of our designed algorithm to the processor, we have to quantize it according to the processor, and the any one ways of these 2 given ways will have to be used for the purpose of the transferring our designed algorithm concept to the processor, either using the graphical representation or using the some languages here. Graphical representation are the block diagram representation, signal flow graph representation, data flow graph representation, dependence graph. Block diagram describes the architecture of the algorithm. Signal flow graph gives the information about the flow of the signals or the information. Data flow graph DFG, it describes the one iteration of our algorithm. Now suppose a particular value of the k, for k equal to 0 or k equal to 1, whatever is the here the number of the processing, this will be known as the one iteration. And if we consider here the all the values of the k, then that will become the algorithm. I'm repeating again it, that is for a particular value of the k, this is a iteration, and for all values of the k, this will be known as the algorithm. So here DFG will describe the one iteration, and dependence graph will describe the total algorithm of the system. Similarly, we can use any language like the prescriptive language C, C++, etc. here. Descriptive language that describes the architecture of the system, and the third one is the applicative language like the MATLAB, Java, etc. These are the applicative languages here. So we can use any one language in order to transfer the design concept to the processor here. And then implementation takes place, and for the purpose of the implementation, we have to understand the application, we have to design the algorithm, then algorithm has to be converted into the implementable form, then efficient implementation of the algorithm will take place, and then implementation of the hardware or the software. And for that purpose, we can convert all the algorithm in such a form that is suitable to given ID, integrated development environment. And for this purpose, for the purpose of the uh, digital signal processing, we will use one ID, that is the TMS, that is the any problem. ID is the Code Composer Studio, and that Code Composer Studio consists this one, that is the C code is given, that is the .c file, and then the next step is compiler. .c file will be converted into the, with the help of the compiler, into the .asm. .asm will be given considered as the input to this assembler here, and we will get here the .out as the output, and .output will be the input of the this linker here, and then we will get out here we will find the .out. So the .c, .asm, .obj, and the .out. .out file is the executable file that will be downloaded to the given target. So this is the concept which we will cover in our this digital signal processing, and we will move one by one. And for any problem, and for the first purpose, first section, I have uploaded 6 or 7 lectures on your class. Please go through those class lectures here. Those are related to the review of the signals, different types of the signal. And since for the purpose of the implementation of these signals in laboratory, there is a need of the MATLAB. So we have also uploaded some lectures on in your classroom, so that you can go through the basic concepts of the MATLAB. And if you have any doubt, then you can ask, and you should ask those questions in the class here. So thank you about this lecture here, and the next day we will discuss the basic concepts of the DSP. Any question? Yes, please. Hello. Have you any question? If you have any question, you can, yes, ask saying something. Yes, sir. Can you please explain effect? Yeah, we will explain it. Please don't worry about any concepts. चिंता करने की जरूरत नहीं। अभी केवल आपके दिमाग में एक इमेज हमने बताया कि आपको ये इमेज ऐसे बन जाए कि क्या क्या हम पढ़ेंगे। ऐसा ना हो कि हम कुछ सब्जेक्ट पढ़ रहे हैं उसको अलग किनारे रख दें, इसको इस टॉपिक पढ़ रहे हैं उसको अलग रख दें। ये हम इनको ऐसे कोरिलेट करते हुए आगे बढ़ेंगे, इसलिए आपको ऐसे बताएंगे। एफएफटी को जैसे हमने बताया डीएफटी का एडवांस वर्जन, दैट इज द in that one we will utilize the concepts or the properties of the symmetricity and the periodicity. तो number of additions multiplication कम हो जाएंगे, प्रोसेसिंग फास्ट हो जाएगी। That's why this is named as the first Fourier transformation। उसको हम पूरा डिटेल में डिस्कस करेंगे। कोई बात की आपको चिंता करने की जरूरत नहीं है, बस ये जो हम लोग करते चलते हैं इसको रोज का रोज आप रिपीट करते चलें और हम निश्चित तौर पर बहुत अच्छे ढंग से इसको पूरा सीखेंगे और अपने टारगेट तक पहुंचेंगे। बस ये जितना आपको अभी जो आपको दिया गया है, आप क्लासरूम में जाएं। ओके, थैंक यू। नाउ यू जस्ट गो टू योर क्लास वर्क एंड सी द मटेरियल्स अपलोडेड बाय मी। देयर आर द सो मेनी मटेरियल्स related to the signals. My lectures are related to the signals. What are the basic signals? How we will represent those signals with the help of the mathematics. What are the criteria of the categorization of the signals and how those signals will be represented using the MATLAB and the basic concepts of the MATLAB. इतना तक आपको उसमें रिप्रेजेंट किया गया। किसी को कुछ भी अगर नहीं समझ में आ रहा, बेसिक्स है, तो भी हम वहां पर उसको सीख सकते हैं। आपके उस पर आपको अपलोड कर दिए गए हैं, मिल गया, आप क्लासरूम में देखें। वीडियो लेक्चर्स आपको दे दिए गए हैं। ये भी वीडियो लेक्चर्स आपको 1 बाय 1 करके अपलोड करते जाएंगे। आपको पूरे वीडियो लेक्चर्स मिलते जाएंगे रोज का रोज, इसीलिए हम रिकॉर्ड कर रहे हैं। आपको रिलेटेड मटेरियल्स मिलते जाएंगे। यू हैव टू गो थ्रू दीज मटेरियल्स और उसको ट्राई करें आप लर्न करने की, सीखने की। ओके, थैंक यू आकाश जी। ओके, so I think this is all about this class. Have you any query? You may ask। और कुछ पूछना चाहिए। Some students has asked the question, बहुत अच्छा लगा।